Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get ready.
Types of internal combustion engines depending on the type of fuel consumed. Internal combustion engines, ICEs, are categorized into types: carburetor gasoline engine, diesel engine, gas engine. Carburetor power units operate on gasoline, using forced ignition. The principle of operation of carburetor motors: fuel in calculated quantities enters the working cylinder after mixing it with air masses. Diesels operate on diesel fuel. Principle of operation: with the help of injectors, the supplied diesel fuel is enriched with air directly in the cylinders. The gas internal combustion engine uses propane-butane gas. The principle of operation of a gas engine is to premix the gas with oxygen before feeding it into the cylinder. Operating cycle of an automobile engine: the operation of a four-stroke engine occurs according to a certain cycle consisting of 4 cycles. The complete cycle is completed after the crankshaft has completed 2 full revolutions or 4 piston strokes. The 4-stroke powertrain in the process of functioning has an increased impact on the crankshaft to power the working systems of the vehicle. During engine operation, the piston makes strokes of 4 strokes: intake, compression, expansion, exhaust. During the intake function, the cylinder cavity is filled with fuel-air mixture as a result of the piston moving to a lower position. Bottom dead center, BDC. As the piston moves to top dead center, TDC, the working mixture is highly compressed. The function of the expansion is to ignite the fuel-air mixture by the high pressure generated during compression or by an electric spark. Upon ignition, the gases expand instantly and push the piston downward with great force. The 4th stroke is produced by moving the piston to the upper position. At this time, the resulting combustion products are pushed out of the cylinders. Features of the engine systems: the 4-stroke engine functions smoothly thanks to the coordinated operation of the auxiliary systems, ignition systems. The exhaust system. Fuel system of the engine. Lubrication. Exhaust. Engine cooling system. The task of the ignition system is to provide reliable ignition of the fuel-air combustible mixture. In the process of operation of the exhaust system, air is supplied in the necessary quantities at exactly the right time to form a quality working mixture. It is the responsibility of the fuel system to provide a continuous supply of fuel to mix with the air masses. Without a lubrication system, the following functions are impossible: stable contact between rubbing parts, removal of tiny metal fragments, arising in the process of wear of rubbing surfaces, removal of increased heat from working elements. The exhaust system is engaged in the complete removal of exhaust gases from the cylinders, reducing the content of harmful substances in them. Cooling system monitors the maintenance of the nominal temperature of the working elements of the engine. 4-stroke engine. Description of advantages: 4-stroke power unit has undoubted advantages: economical fuel consumption, reliable design, easy maintenance, stable operation, high duration of resource, absence of increased noise effects. One of the main advantages of the 4-stroke power unit device includes the original arrangement of the crankshaft in a bath containing machine oil for 4-stroke engines. Whereas in 2-stroke motors, lubrication of the rubbing surfaces occurs by mixing special machine oil with fuel. Due to the improved design of the 4-stroke engine has a small amount of soot in the pistons and in the muffler, which makes it possible to significantly reduce the harmfulness of exhaust gases. Minuses of 4-stroke power units: the main disadvantage of 4-stroke engines is lower power compared to their 2-stroke counterparts. Part of the kinetic energy received by the crankshaft from the piston thrusts is spent on intake, compression, and exhaust. i.e., the energy obtained during chemical combustion processes is partially spent on mechanical propulsion of internal working elements of the engine. During combustion of the fuel mixture, there is a short-term powerful increase in the load on the cylinder head, pistons, and other working elements of the engine. In order to avoid their destruction and failure, there is a need to increase the mass of these components in order to increase their strength. These transformations entail an increase in inertia and loads on the elements in motion. All the described moments lead to a partial withdrawal of power from the four-stroke engine. To the disadvantages can also be attributed the increase in the acceleration period of the car in comparison with two-stroke motors, and the need to adjust the thermal clearances of the valves. Despite the presence of some disadvantages, the obvious advantages of four-stroke power units are undeniable. Peculiarities of four-stroke engine lubrication system operation. The four-stroke power unit is equipped with an oil sump with a sump, in which the lubricating fluid is constantly at a certain level. The engine lubricant is pumped into the system by the oil pump and distributed to the inner surfaces of the cylinder walls. The thin oil film significantly reduces the friction force of the contacting moving parts. Lube rings carefully channel engine oil away from the combustion chamber. Due to the lower loads experienced by the four-stroke engine, a systematic supply of lubricant in the required volumes to the rubbing surfaces of working parts and assemblies is ensured. This significantly increases the engine life. Complete change of engine oil should be performed once a season. To prevent possible leaks of engine oil from the internal combustion engine during operation of the power unit, it is necessary to regularly measure the amount of lubricating fluid in the crankcase using a special oil dipstick. On modern car models, manufacturers install special control sensors, which check the level of machine lubricant and immediately inform the driver about the need for complete replacement of the lubricant. Requirements for engine oils for four-stroke engines: preservation of high lubricating properties over a long period. Ability to provide quality protection and cooling of working elements of the power unit. Compliance with the requirements of the given makes and models of vehicles. If the above points are observed, the lubricating fluid will be correctly selected. The selected engine oil will successfully protect the parts from wear. All the necessary conditions will be created for a long and trouble-free operation of the four-stroke power unit. How the four-stroke engine works. Automobile HBO. In conclusion, understanding how a four-stroke engine operates is essential for anyone interested in automotive technology. We explored the key design features and the principle of operation, highlighting the four distinct strokes: intake, compression, power, and exhaust. Additionally, we discussed the auxiliary systems required for optimal performance, such as lubrication and cooling. While four-stroke engines offer advantages like fuel efficiency and lower emissions, they also come with disadvantages, including complexity and weight. By weighing these factors, we can appreciate the role of four-stroke engines in modern vehicles and their impact on our daily lives. Thank you for watching, and we hope this video has deepened your understanding of this fascinating topic.